introduction. Thanks for your time, Neal, and thank you, colleagues, for accessing this video clip on the actual nuts and bolts, the actual work involved in getting a code standard change. At the moment, I have the privilege of working with Neal Dowling from MT Technologies in Boston. I think we've co-authored 1 or 2 papers. And do you want to say a little bit something about what you do over there at MT Technologies, Neal?
Yes, it's technically M technology. That's M as in magnet technology, in all one word. But our business is to assist clients in doing risk assessments, and we specialize in using probabilistic risk assessment techniques to quantify the probability of bad things happening. Much of our work has involved assisting clients in the data center space, but we've applied these techniques for manufacturers and for non-data center clients, people in process industries, etc. So we are very interested in objective and quantitative techniques for measuring the probability of events. In addition to working for M Technology, I'm also a member of the IEEE 3006 working group, and that working group is responsible for developing and hustling through the standards process, the successor to IEEE 493, which is commonly known as the Gold Book.
I think they're able to see what we're working on here. You know, one of our projects, you know, was on our stack, and why I enjoy working with Neal, other than the fact he's a classy guy and very knowledgeable. And I think we took our differential equations at the same school, did we not? 1803.
Yes, I think we did.
I think we did, and I think Arthur Maddock was glamorized in Good Will Hunting a little bit, if I recall.
Could be, and the guy I took my recitation from went to Stanford and was the thesis advisor for the 2 guys that founded Google.
Oh, okay. Well, we're claiming there's a University of Michigan Google connection here, so it gets to be a very small space very quickly in this business when you're working at this level. So one of the projects I hope that Neal and I can work on is one where we try to assess the economic specifics of the cost of a second service for a hospital. So you and I, Neal, had talked 2 or 3 years ago about, well, let's say if a hospital is going to contract and pay a premium for that second service, in many states and jurisdictions, permit utilities, public utilities, to charge for an extra service. And if you have some metrics, which we get from 1366, what are the reliability or availability considerations that have to be quantified before a decision is made about whether we do that, or to the degree to which we install generation to make up for the lack of availability of the hospital second service. Do you recall that conversation? I hope you do.
Yes, I'm not in incredible detail, but I do remember discussing this with you, and I must say that the addition of a second utility feed to any client premises, regardless of whether it's a hospital, everybody's business is important to them, needs to be looked at very carefully. As you say, it can be very expensive. The utility is allowed and frankly justified in charging a substantial amount of money to supply this. It's very capital intensive and labor intensive, and it consumes a lot of their internal resources. However, from the person considering installing a second utility feed should carefully consider what the expected value they'll receive in terms of improved reliability or availability.
Right now, those decisions are being made by fire marshals.
Well,
very often they are, and that's our point. The reason you guys are important is that you can actually put some numbers to this. These are the same numbers that are used in data centers with the Department of Defense. But in the building premises world, where my argument is that reliability is a safety consideration every much as it is fire, that to get some, to drive quantitative methods such as those you at M Technologies and Bob and others espouse, that it's very important. This is a large economic decision that requires much more, let's say, quantitative treatment than the sort of electrical consultant, fire marshal, what worked last time type of treatment that you often get.
Well, yes, and in terms of convincing authorities having jurisdiction or internal financial people, for example, or the CEO, about how to spend money and what you expect to get in return for that, it is always good to have a well laid out logical case that relies on objectively produced numbers to show that if we invest X dollars for an improvement in an asset, we'll get Y increase in our reliability. Frequently we try to talk about unreliability because most systems are quite reliable, and so you're talking about differences between large numbers. So unreliability is 1 minus the reliability. Unavailability is 1 minus the availability. And as I was saying about having objective analyses, suppose you want to consider putting in a second utility feed, and you should then say, okay, well, what is the reliability I have now, or availability? We probably want to get the definitions of those two concepts established in the standard under discussion here. But you will have a baseline for the way it is now, and then you'll say, well, if I put in a second utility feed, how much better will it get? Through the use of PRA techniques such as fault tree analysis, we can help quantify that sort of thing. And in many cases, and I'll preface this with a statement that in looking at data center applications, it's infrequent that the addition of a second utility feed produces a substantial improvement or reduction in unreliability. And examining why that is the case, it requires a careful sifting through the output of the fault tree analysis. But what happens is a second utility, the assumption that what a second utility feed is going to provide you is that it's totally independent. Its failure is totally independent of the failure of the initial utility feed. And that's only partly true, because at least in the eastern United States, you'll find that the substation that you get the feed from is tied into that other substation at a higher level via the transmission system. So if there's a transmission system outage, I mean an area-wide blackout, both of the utility feeds fail because they're not supplied by their source, and the redundancy that you thought you were getting isn't there. So that if you don't throw your net a little bit wider in terms of how you model the system, you may mislead yourself into thinking that a second utility feed is truly independent of the first one, and it's just not so. In addition, there are site-specific issues to be concerned about, such as how the two utility feeds are physically brought into your facility. Many times, because of various reasons, they may be in the same duct in the ground, and a dig-in could take both of them out. So the issue of common cause failure has to be considered also. And unfortunately, it's a case-by-case analysis, and but those are a couple of issues which I could provide as guidance for anyone facing the question of will a second utility feed produce any improvement in the reliability of my electrical supply, and quantify how big that improvement is or is not.
In the case of the University of Michigan, where we have a $3 or $4 billion hospital or healthcare operation, and a fair amount of investment's been made into that particular campus, Jim Harvey and I were actually the authors of the original service going back into the early 1980s. So now many jurisdictions, I believe we have a couple, 15, 20, 25 megawatt. It's a main arrangement. The capitalization of hospital services is an enormously important decision. Let's say that there's $2 billion of spend just centered in the Ann Arbor campus, U of M hospital campus. A single outage can take you out on the order of $2 to $20 million. So when you have an array, a quantitatively informed array of alternatives, the degree to which you want to spend more money on a second service, or to pay a different rate on the second service, or even consider a third service, with respect to other alternatives that might mean, well, we'll just do something more to our emergency generator lineup, or we could invest more in our district energy system. We have about a 50 megawatt plant. To have this part of our problem quantified, again, as opposed to the decision by precedent, or what worked last time and what will the fire marshal permit us, and even I'm not even sure that JCO is approaching this. So that's why I think the work that Neal does is very important, because I don't see anywhere in the literature for one of the most important capitalization decisions of an electrical power system are made. Are you aware? I don't want to talk. You don't have to talk too much your book here, Neal, but I don't know if even the Joint Commission is informed, and they're the ones that lay out the regulatory framework for most of the hospitals.
Yeah. And we do occasionally assist hospital clients in this, but as I say, the bulk of our work has been with data centers. But I think the techniques are applicable, and if I may interject just alternatives to the second utility feed, and in the context of your mentioning the emergency generator array, another opportunity that may present itself, especially in a large campus such as yours, is the use of continuously operating and independent energy production. So if you have a district energy system, if you it could be gas turbines or whatever that is producing power, and you can arrange your distribution system so that critical loads can draw their power from either the utility or the district energy system, that can have much more impact on improving reliability than just grabbing another feed from the same utility, which is got its own transmission and distribution system.
Right. Well, a lot of that is tied up to heat load, instrumentation, the degree to which you have a load shedding scheme that if there's a shared utility line, very often cogenerations have a shared utility line, and if your generation and your steam load don't match, you will drop a bus, so to say. So it's a very multidimensional problem, but instinctively what I think you just said is that it's probably wiser to invest more in your district energy system than your utility. But you can't again, unless you get some money, unless you get approach this from a quantitative in a quantitative manner, this $1 to $10 million per year decision is not very informed. That's one that runs out, for the life cycle of the entire hospital campus. So
yes.
It looks to me like we have Bob on the phone. Hi, Bob.
We do. Hi.
How are you today?
I'm going crazy. Sorry I'm late.
No problem. I'd like to say those of us who are employed or overemployed. Bob, I've spent a few minutes here with Neal. I'm recording this for the benefit of people in my industry, particularly Jim Harvey's group, when we'd like to get wiser, so to say, about how we make decisions in power supplies to hospitals. So while we were waiting for you, I tried to point out to our listeners that before we came to the scene, there was not a lot of sentiment or understanding of what quantitative methods were in the National Electrical Code space. Now I know in the data center space, obviously in the Department of Defense where you are, you've always approached them that way. But in the building premises wiring world, that it has not been elevated. It has only recently been elevated that there are quantitative methods for making some rather important safety as well as capitalization decisions. So that's kind of where we were, and I wanted to let you know that this is a bit of background to what we're actually trying to do here today. And so I just want to welcome. This is essentially a recorded teleconference, and there might be maybe 20 or 30 other people listen to it. And I just want to make sure that's all right with you. And if it isn't, then we can change that.
No, it's fine.
Okay, so you'll have a chance to listen to what this is all about, and I'll give you a little more background. We are running up against a time constraint, though, and two things have come up. We were talking a bit about the sort of stopgap proposal that I put in as somebody who just wants to get reliability defined and on the agenda. And then I think Neal is going to propose something a bit more, probably a better proposal than mine. And then I thought, my hope that our takeaway here today would be how we take your proposal, which I think is still on the screen. Is that what I see this? Is that what I see here?
Yeah, that's what I see.
Is that yours? Is that yours, Bob? This is yours, right?
Yeah, NXF, yeah.
All right. So are you, my hope is I could actually show you and walk you through how you enter this in your own name.
Right.
It's not that difficult, but we do need you to log on to your own NFPA site, or at least in your own NFPA account. Is that all right with you?
That's fine. As long as I know how to do it, that's fine.
Oh, okay. Well, you know, at this point, I'm thinking here, this might be even too granular for our audience. One thing I'd like to stop the recording right now because I think this might be a little bit too much into the weeds for us, for other listeners. I wanted to summarize some of the prefatory discussion between Neal and I. And having your point of view is important here also.
Okay.
Could you say a little something? So what you're gonna do here before I stop the recording is, could you say a little something about this document here, because this is where we're going to be making a change to the 3000 series. And if you can see what I've done here already, here's what I did, because I didn't know if you guys would have the time. I simply did this. And I know that you and I had talked that maybe it may not be ready, but remember that 2017 will not be out until late 2016, and we're thinking that you would already be ready for market here.
Well, we're basically you're referencing two different types of documentation here. So the IEEE 493, which is called the Gold Book, is more of a comprehensive combination of subject matters, all related to reliability, all related to the power industry, and designed to introduce the non-reliability engineer to the different concepts of what reliability statistics, the basics is, and then bring him through and show him in examples of how to apply some of those principles. In addition to that, the many chapters that are in the Gold Book, you will also find concepts in terms of optimization of your facility as it's related to the ultimate reliability. And then, of course, in the back of the publication, you'll find the data of the information of where you can gather, the basics of the analysis and calculations. Now, what we're doing in the process here is we're converting each one of these chapters into what they call a dot standard in IEEE. So each one of these standards or each one of these chapters are being converted over to kind of give a little bit more detail. They're kind of designed to stand on their own, so you've got to have a little flavor of, you know, the application of reliability, and then for that particular one you're talking about, it's going to give you examples of how to apply that. So it's a little bit different approach, but it's a process that we're going through.
Mm-hmm. Well, as I mentioned, I apologize, it is a stopgap. It does qualify. As it's written right now, this is enough to get it on the committee agenda. We know that typically they're doomed to be rejected unless you work a little bit harder. So what you would come back around and say, well, it's not quite the same of the general treatment you've given in 493. That probably includes emergency and standby power systems.
Yes.
But you want to get more granular about it, and I think that's what your point of the 3005.4 series is anyway, is that yes, they wanted to leaven the material, make it move faster. It has a chance of being updated even more than every 5 years if it's a little faster and lighter. So this is not quite true, but it was me trying to, I fielded the ball as a shortstop and I bobbled it a bit. But it didn't go out into the outfield. And my hope is that you guys will come along and fix this to the degree to which you think it's possible. So I'm going to stop the recording here and thank my colleagues. Bob, do you want to say a little, are you able to say something a little bit about what you do for Excelis?
Sure. I am the manager of a small group, and we basically do a lot of government contracting, especially in the intelligence community. And what our group does is actually apply a lot of the Gold Book concepts in optimization of power and cooling and control systems and several of the aging facilities around the world. So we get to actually at firsthand look at the application of some of these techniques, and we use these techniques all the time. In order to identify, you know, optimization of these facilities, and then we go into a estimated cost estimate and a new design to bring them up to not only current code standards, but also to current mission requirements for each one of these facilities.
Yeah. What I like about Neal and Bob is that they're actually with IEEE. There's a lot of engineers in the data center space, many of them turnkey oriented, and I don't know if there's any other thought leaders. I don't know of anybody, two other people that are able to stay close to where the global action in reliability metrics are, and also work are developing as consultants tools for making rather large capitalization decisions. So I don't want to, maybe I didn't say that as well as I could have, but in general I admire your work, and I consider it a privilege to be able to work with experts such as yourself and to convey the quantitative methods that work so well in other industries into the NFPA world, the building premises world. I think that's where we need to go, and it's been quite a lesson for me, and I'm grateful for it. So at this point, I'm going to stop the recording, and we can start writing, if you don't mind. Thanks, gentlemen.